So in this problem here, we have a ball that's thrown at an initial speed of 25 meters per second. And so that means that it's thrown up something like this, where this vector's length is 25. But we know with velocity, we have horizontal and vertical components. And so if this is angle alpha, the angle that it's thrown at, this is going to be 25 cosine alpha, because it's the adjacent, and this is 25 sine alpha. So my initial, when t equals 0, I know my velocity is going to be 25 cosine alpha, and 25 sine alpha is my initial velocity at 0. But how do I even get there? I have to recognize that this is a ball thrown on Earth. And so my acceleration is going to be 0 for the x value. Going this way, there's no acceleration. And then, but the y value though, gravity is pulling on it. It's always minus gravity, which we know is 0, negative 9.8. And so there is our acceleration. If I want to find the velocity, then I take the integral of that. The integral of 0 is just some constant c. The integral of negative 9.8 t is add the variable, and c2. This is my formula for velocity. I take the integral of the acceleration. And so then to find when t equals 0, it's going to be these values here. And so I can say my velocity is equal to 25 cosine alpha, negative 9.8 t, plus a 25 sine alpha. Okay, and this is going up is positive. All right, and so now, as we continue going through at 3.5 seconds, it's descending at an angle of 45 degrees to the horizontal. And the fact that it's 45 degrees to the horizontal is actually important, because 45 is the only time that the components are equal. So what that means is this projectile is coming down in such a way so that the velocity here and the velocity here, if this is 45, that means these components are equal to each other. And this happens at t equal 3.5 seconds. And so I know because it's 45, the vertical and horizontal are equal to each other. Now, so my horizontal is 25 cosine alpha. But because this is going down and defined up by convention as positive, I'm going to multiply by the negative as it's going down, negative 9.8 t plus 25 sine alpha. And so 25 cosine alpha equals 9.8 t minus 25 sine alpha. And this happens when t equals 3.5 in here. And so it's 25 cosine alpha is equal to, when I plug in 3.5 here, I get 34.3 minus 25 sine alpha. And then when I actually graph this on my calculator, if I go from 0 to 90 and I go up to 25, I get one graph comes here and the other graph comes here. And my answers here, this is a 31.2 degrees. And this one here, stealing at my answer key, is 58.8 degrees if you do it graphically. But ultimately, thinking about this, the key to this is recognizing acceleration is negative 9.8, and that's always constant in projectile motion for here on Earth. Our velocity breaks up into components, a vertical and a horizontal, with up being positive. Integrating the acceleration gives us our velocity. And then the last part here, recognizing that when it's coming down, if it's 45 degrees, these two components are equal. And then we can solve the equation graphically.